Good morning, everyone. Thank you for joining us for today's first session. My name is William Elliott from White Rook Cyber. I'm the session chair. If I could just remind everybody that if they have any questions from today's session, to use the app. I'll get to them after David has spoken. So with that, I'd like to introduce David from Airlock. David is an experienced cybersecurity practitioner and has a wealth of security operations and consulting experience within organisations including Microsoft, Telstra and Australian federal government. As a result of his practical experience implementing Allowlisting, Airlock Digital was created to solve modern endpoint security challenges. He has authored SANS SEC 480, implementing and auditing the ASD top 4 mitigation strategies. Welcome, David.
Thank you very much. Thanks for having me. And yeah, welcome everyone. Thanks so much for coming out this morning. I know sometimes second day of the conference early on, it can be a little challenging. But today we're going to be talking about what is all about application control, right? So what is application control? We're going to be talking about some engineering essentials, making it realistic. We're going to be talking about the challenge of file trust, which is something that's really a difficult problem across industry in general, and talking about some of the business processes that you can implement in order to make application control easier. I really want to try and give some practical advice that you can take away during this talk, rather than it necessarily being, vendory, right? Because my background is security operations. I'm a practitioner at heart. So I guess what is application control, right? I'm sure many of you in this room already know this, but for those that don't, it's a way of choosing sort of what files you trust and blocking everything else, right? And by doing that, you're preventing all unknown code from running. Attackers can't execute their ransomware, their malware, and it's a really effective security control. It's only more relevant today than what it was when I sort of started Airlock in about 2013, and it just hasn't gone away. I'm actually surprised that there's not a lot of other security vendors that are coming on the market actually trying to address this problem. It's a cybersecurity strategy, and strategy is a really interesting word. The ACSC Essential 8 calls these things strategies because they're not just a control that you implement, right? They need to be implemented and maintained and change as your organization changes, right? Because otherwise you're just implementing antivirus. In the same way that you don't just implement patching, right? You need a strategy around patching where you update and deploy patches and therefore it stays effective. And application control has to change as your business changes. It's really effective, as I've already said, and there's people that keep searching for alternatives, right? A lot of the signature-based detect the bad in amongst the good isn't really getting the outcomes that people are looking for. But I think it's important to look at some of the 101 and some things that seem obvious but kind of aren't. And I guess talking about what is an application, right? It's something that we as a company that does, application control often debate internally. And the industry calls it application control and ACSC does, but is it really about applications, right? I don't really think so. I think it's actually about files. And therefore, a few vendors, including ourselves, call it Allowlisting. And I'm going to refer to it as that, throughout the rest of the presentation, because we think it's about allowing what files you trust rather than necessarily the applications themselves. Because, application invokes visions of an executable that you run, and that's it. And this graphic that's on this slide really demonstrates, I think, the nature of the challenge when we're dealing with Allowlisting, which is this is an Adobe Reader 11 installation. On the left-hand side, you've got the Adobe Reader executable that runs. When you run it, it explodes into 3 files, and then they, during the installation process, explode into about 100 different files. And then you end up with about 70 different files at the end of the installation. And in order to get a security benefit from that, you need to trust every single one of these files and associated libraries across that entire chain. And that's challenging to do at scale, right, which is what we're talking about today. So I've sort of defined what an application is, which I think it's a collection of software libraries and configuration files that work together to perform a common purpose. So what are our objectives? We're trying to prevent untrusted code, as we've mentioned, and in order to prevent malware, you need to control file executions, as I've said. On average, we see that organizations have about 70,000 different pieces of executable and script content at a minimum across the organization, and that on average is from about 150 different vendors. There's a lot of different software out there once you really start digging into it. And also, on average, we say that customers should see around 100 new files a day if you've got over about 1,000 endpoints. Right? If you're implementing Allowlisting and you're not seeing regular new files that are coming in, then you probably want to question the efficacy of the control, because users bring in new files into the organization all the time, whether you like it or not, from different sources. So it's important to actually see block events and see exceptions, because that's telling you that the control is providing a benefit and it's working. Success is not silence. It's important to also understand what Allowlisting is not, and this is defined by the ACSC, and it's not providing a portal or other means of installation for approved applications. So it's not just a web page that you click on and get the applications you want, because that's not controlling the files that we talked about. It's not using web or email content filters to prevent users from downloading applications, because again, that's not controlling the execution of files on the endpoint. It's not checking the reputation of an application using a cloud-based service before it's executed. And that's because of context that relates to your organization. And I'm going to talk a little bit about context soon. Or using a firewall to identify network traffic and block it, right? That's not controlling the execution of files on the endpoint. And the reason that's mentioned, and the ACSC specifically calls it out, is because there's a lot of I guess, miscommunication and creative marketing from vendors across the industry as to what they can and can't do, particularly as it relates to this, which is the Essential 8 maturity scale, right? There used to be, there wasn't, and then there was, and now there isn't again, a maturity level sort of 0, which is you not implemented or you're in order only. And essentially what this scale does is it's saying that if you get to maturity level 3, you're really tightly controlling all of those files that are across in that graphic that I showed before. You're controlling scripts, installers, recommended block rules, which is essentially hardening. So you're blocking components inside your operating system to reduce the attack surface. We want to aim for maturity level 3, but it's important to walk before you run. So sometimes it's okay to actually aim for 1 and then work up that scale. But 1 is essentially, and I'll sort of call it out, 1 is app locker, which is you're preventing executions in standard user profiles and temporary folders, which is what app locker is designed to do. So I guess what's the problem, right? Allowlisting has been considered too hard. That's why a lot of you are here, because it's a really difficult thing to do. We want to try and make it easier because we know that it's effective, but it's difficult. And as I mentioned, I'm surprised that no other vendors have come along to actually try and solve this problem. But I think the vendors that have come along and the solutions that are there on the market aren't actually solving the right problem. And it's not really a technology problem, it's a process problem. There's so many technologies on the market that can allow and block files. We've done that all the time, but it's the process of how do I capture all of that file information, bring that together, make those decisions within the organization and our business processes, which is the challenge that needs to be solved. So you need to be able to make decisions at scale and close that feedback loop. And I wanted to talk a little about how we go about doing that. So I'm going to call this the app locker problem. And this isn't a dig at app locker, right? This is just outlining the intent of what it was designed to do, right, in its default configuration. So, and I do encourage you all to, have a go, try and get AppLocker inside your environments. And there are a number of organizations that are successful in doing so, but you've got to understand that there needs to be some engineering around it. So out of the box, when you have, if you want to do Allowlisting with AppLocker, this is what it looks like. You start with an unknown file, there's a block event, and then that block sort of stays on the end computer, right? And then the user calls up and says, hey, my application doesn't work. They log a support ticket. The support member goes and gets the logs. The administrator then formats the logs. They update group policy, and then they just kind of wait. Like, is this going to happen again? I don't know. I'll wait until the user calls me again. And the thing that's missing out of this flow is centralized logging, right? So what we need to do is the first thing, and it's a requirement, is centralized visibility. We need to cut out the user calling me. If the user's called you, it's not going to work when it's the first time you're finding out about it. And you need to cut out the obtaining logs manually, right? And the way that you can do that is by using, any sort of SIEM product, right? So Splunk, other things like that. So you've got an unknown file block event that logs to the SIEM server, and then the administrator can format the logs, update the group policy, and then just hanging around waiting turns to monitoring. So you can actually see that when it happens and try and get ahead of the user so that if the user does call up, then you've actually got a solution. However, this is still too slow, right? You might cut the time that this takes in half to about 15 minutes, but 15 minutes is a long time because if a user wants to join a meeting, such as a WebEx meeting, and you don't have the WebEx software installed and you need to allow it, then they've missed their meeting in that time frame. And you do that too many times, then Allowlisting gets kicked out of the organization because of the negative user experience, because they say, hey, it's impacting my productivity here. So what we need to do is we need to remove more steps in this process. So the next step is rapid updating, which is a requirement. So you need to be able to get those events into your rule set or whatever your enforcement mechanism is. And I've sort of done this a little bit manually with app locker, and also like even semantic endpoint protection has an ability to sort of have a list of hash values that you can push hash values into. And you can write a wrapper. There's some that's available on the internet that you can plug into different SIEM solutions that can basically do some plumbing between your SIEM product and whatever your rule set is. But you need to be able to get that event, push it into the rule set, and have that flow through your environment. And then your role just becomes monitoring. So you're not manually formatting logs. So you need to be able to update rapidly and frequently so that when someone needs to join their WebEx meeting, they can do that. And therefore, what you've done is you've sort of closed the loop at that point. But we're still left with really one of the biggest challenges that's across the industry today, which is trust, right? How do I know what files to trust, when I see one? It's something that the industry just grapples with generally. Is a file good? Is it bad? Is it both? Because there's so many files that can be used for good things, but also be used for evil. And I was sort of thinking about this, and the Oxford Dictionary defines trust as the firm belief in the reliability, truth, or ability of someone or something. And that doesn't really describe the trust problem as it relates to file-based security. So after a lot of thinking, I came up with this definition as it relates to trust, and it's the firm belief in the purpose, origin, and expected behavior of a file or a software package. So you need to know really three things when it comes to trust. You need to know why is the file there and should it be there? What's the purpose of it? You need to know where it's come from, and you need to know the expected behavior of it, right? And if you know those three things, you have a pretty good idea of whether to trust a file or not. And that goes into three different sort of domains, which is, I think it's context, predictability, and integrity when you're stuck on choosing a file to trust. So for context, the file must exist to serve a particular purpose and be attributable to an application or a function. So you need to ask why. Why does the file exist? And what's important to know is you as the organization are really the only one that's in the position to answer that question, right? Other vendors, when you've got cloud-based definitions and things like that, can't give that context because they don't know whether you use that application, whether you don't, whether PS exec is a good thing in your organization or not, right? It might be, it's probably not, but context is important. And some of the questions you can ask when determining context are, has the file been seen by a large amount of users? What's the prevalence inside your organization of this file? If there's a file on 900 machines, it's either that you're really owned or it should actually be there, right? So has the file been signed by a vendor? Is the file located in the correct path for its application? Or does the file have sort of a description that's trying to explain its purpose? All of those type of things gives you a little bit of context about why is the file meant to be there. Then there's predictability. Predictability is something that can be solved in sort of a pragmatic way by a lot of solutions on the market. There's sandboxing, there's EDR solutions, look at behaviors and try and understand when something's predictable or not. And really for predictability, the file must behave in a predictable and consistent way when it's executed or handled. People should ask, does it do what it's meant to do? Like if you've got a hello world script that's pulling down files from the internet, then that's probably not consistent with the behavior that it should should have. So you can ask, when is the file run? Does the file request any sort of elevated permissions? Does the file load into the expected process? Does it perform any system modifications? And does the file extension, sort of match its content? There's some of the things that you can sort of think about when we're talking about predictability. And Then the third is integrity. The file must provide assurance that it hasn't been modified or tampered with in any way. And you can obviously the number one thing there is, does the file have a digital signature, and is it signed and is it valid? Does the file's hash value match a vendor provided hash value? And some vendors are really nice and they provide a list of their software. Or has the file changed hash value since I last seen the file? Right? But probably the easiest thing for integrity is does the file's hash match a known good sample based on threat intelligence? That's what threat intelligence is meant to solve. So if you can sort of figure out those three things, then you can have a good idea of trust. And you're probably thinking, well, that's great, but how do I do that 10,000 times? And really quickly, it's just not practical. And I guess the reason for that framework was really, there comes a time in Allowlisting where you get stuck on certain files and you're like, I have no idea what this is. This is strange. And that provides a good method of thinking when you're going about trying to understand that problem. So context can really be solved in this flow by plugging in a threat intelligence source into it. Just get a sanity check on those hashes. You can plug in something like VirusTotal. There's plenty of other providers out there where you can just programmatically query the hash values of files, because Allowlisting is, fundamentally you need to have the hash value of a lot of those files. Right? And there's a number of ways you can do that in sort of a low-cost way. It doesn't all need to be, super enterprise scale stuff. There's a lot of open source threat intelligence and things like that. So I guess what I'm really highlighting with this is there's some process challenges that you need to focus on regardless of the technology that you use. And I've used AppLocker as a basis here, and it does require a little bit of plumbing. So as I mentioned, how do we take all of this file information and make those decisions at scale? And it's really all about data analysis. The amount of sort of Excel spreadsheets that I've seen from organizations that try and solve this problem is quite staggering and also really impressive. There's a lot of good people out there that are really good at Excel. But there's this project called AronLocker, which does this for AppLocker, right? It takes all of the block data, puts that into Excel workbooks for you, and displays it in all sorts of different ways. And all you're doing is you're cutting the data with different views. But the general principles of how you really want to manage that data is you want to deduplicate that information first. Because when you first deploy Allowlisting, you will get 10 million events that come in, and you'll just be like, how do I even start? And the first thing is deduplication. Files run more than once and they generate more than one block event, right? But when we're talking about making decisions, we only need to allow the file once in order to allow it to run multiple times. So deduplicate it, compress that data down. And then what we want to do is we want to find commonalities in that data, right? So we want to group it potentially by applications, right? We want to try and understand how all the different file components relate to an application. And you can look at that by saying, okay, what are the common file publishers? That's the easy one. What are the common file paths? What are the common processes that link all of these files together? And if you can draw a thread through your data set of saying, okay, I'm just going to draw a general group around this collection of files, trust those, come back tomorrow, have a look at what else has generated exceptions, then you're really quickly sort of cutting down the data set and starting to get to those exceptions where you have to use that trust decision thinking that I talked about earlier. So once you've grouped those, trust those, and then work through those exceptions on a case-by-case basis. And ideally, you want to try from the start to embed some sort of audit process in order to have a record of what's actually happened throughout that time. Right. The only other approach, if you're not doing this and you're not making the decisions, is getting another vendor to do this for you by having that cloud reputation. And as I mentioned before, the one-size-fits-all approach, it works and it's appropriate for a number of organizations. And but they can't give you that context why the file is there. What they're deciding is the integrity and the predictability only, which is just, is the file malware or not, right? And I don't think it's really Allowlisting personally, because the security benefit that you get is when the trust set is specific to you, and therefore attackers can't game it. It's important to note that Allowlisting doesn't scale with an organization's size, right? So the effort to maintain Allowlisting correlates with the maturity of an organization's software management processes rather than their size. If you're an organization where you just allow users to have administrative access and they're able to install whatever they want, the first challenge you're going to have is none of this. It's going to be a culture challenge, which is how do I get that behavior into a process where we can actually get the software down there into the endpoints in a managed way. And I would suggest that you're probably not ready for doing something like Allowlisting if that's the state. You want to try and make sure that you're patching, you're delivering via some sort of centralized or managed mechanism first before you try and do this, because that culture piece is something you're going to get a big pushback on, and then you're battling that. So treat that as a separate thing if that's your problem. But really the impact is nearly always on administrators, and the one that everyone loves to talk about is developers, right? Because the whole point of developers is to create new code, and the purpose of Allowlisting is to prevent new code. And there's a catch-22 there that's really kind of hard to reconcile with. And I'd love to talk about that in the question section after this talk, and how we might want to think about that. Standard users really rarely encounter blocks. They use the same applications that are on the endpoint all the time. It's the people that step outside those bounds that are the challenge. So if you're thinking about where to deploy it, I know organizations will say, we said we'd be maturity level 2 across the entire organization for Allowlisting, make it happen. But I wouldn't be worried about actually trying to say, okay, let's do all the standard users first. Let's get that done, and then let's try and work on some of the more tricky exceptions, and therefore you're getting a security benefit out of it. But what about the business considerations? This is sort of a process, a problem, as I mentioned, and you have to embed Allowlisting into the business, right? If one team is doing Allowlisting, if you're saying security team assemble, and they're the ones that are just doing it, you're not really going to be successful. And the reason being is because, again, we talked a lot about context. The security team doesn't often understand, especially in large organizations, what software is going out in the endpoints, when, and all the management processes, right? And that's just because the security team is concentrating on different objectives as part of their work. So I would argue that your administrators of your servers and your desktop fleet are the ones that should perform policy administration. And I know there'll be security teams like, I can't trust them to do that, that's scary. But it's the only logical way that this works, right? If you want it long-term inside the business, right? Because they know when an application's being deployed, and they can go and trust that. Then you engage the security team to perform decision oversight of that, and also data management. So Allowlisting generates a lot of great hash values and a lot of great data out there in your environment. So go and threat check that data, have a look what's running in your environment, and that can inform the security team with a rich source of data, in order to perform incident response and other things like that. You can even just throw those hashes even into a database or something that, if you do get some indicators of compromise for different organizations, you can just check to see, hey, have I ever seen this hash, right? Even if it's just, there's no context, you're just like, actually I have somewhere, and then they can respond to that. So it's not all out of control for the security team. And the last one is exception management for the help desk. Just like I talked before about WebEx, being someone needs to join their meeting, they're going to call the help desk. They're not going to call the SOE team or the security team. And if they have to, it's going to take them more than 15 minutes to get through to get that situation resolved. So you need to sort of empower that level 1, level 2 help desk to be able to issue exceptions, when there is a need to do so. Because allow them to get on with their work, because if you don't, then it's slowly going to roll backwards and be removed from the organization. And again, that can be a scary thing for security teams. you need to document that process and communicate the change. So, hey users, we're implementing this new security control that's out there. If you do get this block and you see this thing, you need to follow this process, because otherwise people will just think that things are broken, and I've seen it many, many different times across enterprises. So they need to know the change is happening, and also a process for how to troubleshoot for your administrators, right? I always say it's better to notify the user that there's a block, because when a very long time ago, I was doing endpoint administration, and essentially the blocks were silent, and what that causes is your application's broken, and then it takes 20 minutes for some administrator to figure out that, it's Allowlisting that's causing it, and then that makes them very not happy because you've wasted their time. They just keep starting to blame the control, and then you end up in this defensive position. So it's important to be transparent to that end user. When there's a block, make sure that you're notifying the user on the endpoint. And empower the users in a risk-based manner. This sort of goes to that help desk exception management. Don't get caught up on the risk. During implementation, people always go, oh no, we can't give out these exceptions. We can't put these rules in place. And it's important to remember that unless you're doing this already across your organization, then you're allowing code to run arbitrarily with no visibility anyway, right? So you've got a permanent exception, if you think about it that way, across your entire organization. So, don't let the decisions slow you down. What you can do is you can say, right, help desk can just issue exceptions wherever they want. We're doing that for rollout 1, and then we will start to look at the reasons that users are getting tripped up on the control and requiring exceptions. We'll understand those reasons and we'll try and fix them before we actually tighten up the process. It's a much better way to actually go about doing that. So with the deployment flow, how does this all really come together? And the number one thing, or the first thing that you need to do, is really decide on that maturity level that you're looking to get to. So that was back on the maturity model that I showed. Are you aiming for maturity level 1, 2, or 3? And understand what that means, because 3 is obviously more work, and you need to make sure that you need to get there, right? And then also understand where you want to deploy it inside your organization. You need to have a look at the technology you're using and understand if there's any engineering that you need to perform. I talked about AppLocker and some of the pieces that you need. Make sure that you've got the centralized visibility. You're closing the loop and you're able to push stuff or rule sets into the policy quickly, and understand where there's gaps and where you have to engineer for those gaps, because every technology is different. Then step 3 is developing those business processes. How do we do exception management? Who's going to own the solution? That's probably the most important thing. Who's going to manage the rule set? Who's going to take advantage of the data out there? And then step 4 is to roll it out and actually iterate on that. So really those key requirements: centralized visibility, have a process, ability to update rapidly and frequently is key, and then look at the method for temporary exemptions and get your responsibilities embedded across the business. I guess before I go to questions, I sort of touched on something which was about developers. I'll just talk to it. Essentially, the purpose of everyone says, well, right, we've got Allowlisting in place, but this does not work for my developers because they're sort of allowing code to run. So how do we allow list developers? You've only really got one choice because of that catch-22, which is you need to provide them a mechanism where they can compile and run code. Ideally, the best thing you can do is with their code editor of choice, which is like Visual Studio or whatever it is, you have tests, let's say code signing certificates for them, and you trust those certificates during the compilation process. So when they compile and they go to run code, the editor or the IDE will actually go and sign that code and then try and execute it, right? Which won't trip over that policy. That's the ideal way. But many developers will laugh and be like, well, that's not practical because I just want to, bash out this script and, it's getting in the way of doing my job. The other way is you need to carve out an exception that's on their endpoint to allow them a play space in order to do work. And that might be, you've got a particular development folder or a development drive somewhere in order to do that. Ideally, you want the rules to be as strong as possible. So you might say, okay, well, these processes on my machine are allowed to execute code, but nothing else, ideally. Or you can go down to the path rule stage, which is like this part of the computer you can actually use. I haven't really, and I've like to think that I've thought about this problem for a long time, come up with any other solution, that works better than that. And many people will say, well, what's the point of doing allow listing for developers? What I would argue is you're doing risk reduction across other parts of the computer. So if the developer's pulling in stuff from the internet and they're just executing it out of their downloads folder, you're preventing a risk there. And again, it's not realistic to get 100% Fort Knox coverage across the entire environment. You've just got to be realistic about it. So I hope that provides some some interesting thoughts about how you should approach application control within your business. And again, I don't really think it's necessarily about the technology or the technology problem. It's just about those process problems. Getting those right, you will be far more successful in getting this control inside your environment. And most importantly, keeping it in for the long term with that strategy piece. So making sure that it's embedded. So thank you, and any questions?
Thank you, David. We do have 3 questions for you, so in order of which came in first. So we have a question here from Neil. You mentioned that an organization would have 100 new files a day. To make an informed decision on allowing whitelisting these files, what steps would you recommend?
Yeah, so I think the first thing is looking at, taking that thinking about the trust model. I guess the first thing there's a couple of approaches. You can log in once a day, have a look at those 100 files. You can go through them in a granular way. Or what I would recommend is you would set up a number of rules about when you choose to trust a file based on certain things. So you could say, okay, well, if it's come from these particular users or these processes, then I'm just going to allow those because I trust it. If it's digitally signed by a vendor, I'm just going to, trust those files and try and have some baseline rules about what's acceptable for you, because, the risk decision is going to be different for every single organization. Some customers will just go through, or some people will just go through and they'll just trust everything, right? They'll select all 100 files and go done. I don't recommend it, but what I would say is, okay, well, if that's what you want to do, then you're still getting a security benefit because you've stopped that code allowing to be able to run at least once, and then if it was ransomware or something, you've actually stopped that from executing. So again, it's just about being realistic. But yeah, I would set up a series of key points that you're comfortable with, or attributes, when you're looking at this file rule set. Stick to those, allow that to speed up your trust decision, and then apply that sort of trust model as much as possible to the remaining files. The biggest thing that can speed this up is threat intelligence as well. So if you're checking those hashes against a threat reputation service, you could say, okay, well, 60 files out of this rule set are known, and then I'm only looking at the other 40. And because that's been scanned by AV and the cloud says it's okay, then I'm just going to accept that, and then I'm going to move on with the rest of my rule set. So I think it's, again, just about the process and how you make the decisions.
Excellent. All right. Question number 2. You talked about help desk for exception management. Wouldn't that be a prime target for social engineering?
Absolutely. Yeah, it totally would. And I guess that's why, it's important to test those processes. But it's a maturity journey. So at the start, allow the help desk to give out those exceptions, and then you can get allow listing in, and that's acceptable. Then you're getting that security uplift. But then second, it's about having a look at why people are requesting those things. So you might say to the help desk, why is that happening? And then you might tighten the process. So you'll say, okay, now we only give out exceptions for the following reasons. And then you sort of try and tighten that up. I think for help desk and social engineering, it's important to be able to try and validate the end user as much as possible. And that's sort of outside of the allow listing challenge. That's just general, help desk could be social engineered for password resets, or a lot of things which would actually give the attacker, sort of not having to run applications in order to be on your endpoints anyway. So I think it's the main thing to stop social engineering is really just understand who the end user is, authenticate them in some way, and through Allowlisting understand why they want to run it, because you should be able to trace back the request to some sort of event. They're only going to call you if they get blocked. So you should be able to do, you know, some sort of challenge response, and maybe you give the help desk the ability to actually look at the file data but not actually change it. So they could search for you know, a particular user that's called up with the request and see that there's block events there.
They're coming in thick and fast. Are there any other tools that you recommend to assist automating trust decisions?
Automating trust decisions. I think it's about you know, sandboxes are really useful if you've got some really tricky ones. You know, if you can get a copy of the file and you can throw it into a sandbox, then that's really good analysis. You know, I think. Yeah, it's really making sure that you've got a good investment in your security stack, that you've got something that you can rely on for behavior. You know, EDR is really good at this. It's obviously the best. Sandboxes are a little bit of a manual process, but then you can throw things into a sandbox and get a report. But really, threat intelligence is the thing. They've sort of done that already for you, kind of at scale, and then you can just use another technology. But in terms of open source tools, yeah, there's nothing that really encompasses all the different file types. You can bring certain tools together for certain files, like, you know, the only thing I can think about at the moment is something like OLEVBA for, there was a project to disassemble sort of like macro code and tell you whether it's dangerous. It's open source. So I think it's just, yeah, for executables, it's really EDR and threat intel.
Excellent.
Sandboxing.
This is a good one. Can Allowlisting help manage the supply chain problem, like the recent 3CX incident where an already trusted application suddenly became malicious?
Yes, I would argue it can. This is something that we talk about a lot, which is like, hey, you've trusted this code signing certificate, that's great, but what if it gets stolen? What I would argue is, you know, when you're doing Allowlisting, you've at least got the mechanism in place to revoke that trust, right? Otherwise, what you're doing, if you've got another security stack, is you are just waiting for the vendor to actually revoke that or mark it as bad for you. And there's always a massive lag time when that happens, if your vendor gets to it, you know, and it really takes a lot of customers sometimes to actually call up their vendor going, hey, what's going on with this? Whereas Allowlisting should allow you to actually, you know, target, revoke. At least you will know also whether you're impacted by something like the 3CX thing, because quite often you can search for code signing certificates, or you will have a list of hash values where an attacker signed those bad files. I think it was in the SolarWinds hack, you know, we had binaries, hash values that you could search and say, are these in my environment? I'm going to actually remove that from the trust list. So at least you've got the mechanism in place, even though that mechanism allows the code to run. But again, if you're not doing this, then you're arbitrarily allowing code to execute anyway. So, yeah.
And this will have to be the last one. Have you seen threat intel for a higher level allow, such as allow by code signing cert rather than the hash by file hash?
Yes, I mean, like a lot, I guess with that question, is it sort of talking about using certificates just to allow files rather than hash values? Yeah, okay. So, yeah, I mean, that's... I would argue that Allowlisting doesn't really work or isn't practical unless we can trust the code signing certificate, right? You need to be able to do that to leverage scale, and that's probably the prime example is Microsoft Windows updates. You have to be able to trust the Microsoft code signing certificates. It is not practical to get all of the hash values across the operating system, anticipate the hash values of patches before they get deployed, and then manage that whole flow. And also, if you're trying to do that, people are going to get lazy, and then that's when they're going to go, this is too hard, I can't do it. So you have to be able to trust digital signatures. Now, there's two different ways you can do that. You can look at different attributes of the certificate. You know, some vendors will look at, okay, well, here's sort of the common name and some of the certificate attributes. Some vendors will look at the certificate thumbprint, you know, and you can allow different thumbprints. But again, risk reward. The challenge of digging down into those thumbprints is that vendors don't tell you when they're updating to a new certificate and suddenly something's going to be blocked. So again, it's about finding that practicality balance, defense in depth with everything we do when it comes to security. Yeah.
That'll have to be it, David. Thank you so much. On behalf of the AusCERT organising committee, we'd like to thank you for your time and give you a very limited edition.
Thank you, everyone.
Back to the Future one.
Ooh. Very nice. Thank you so much. Cheers.
Thanks, everyone. That concludes this session. The next one will be in 5 minutes' time. Thank you.